Welcome to Neotech Lens, your ultimate destination for the latest updates on cutting-edge technology, AI innovations, futuristic gadgets, and everything shaping the tech-driven world. Stay ahead of the curve with insightful content, breaking tech news, and in-depth discussions on how technology impacts our daily lives. Join us to explore the future, one lens at a time.
For centuries, humanity has dreamt of creating artificial beings in our own image. From ancient myths of golems and automatons to the futuristic visions of science fiction, the idea of humanoid robots has captured our imagination. These creations have always symbolized both our aspirations and our fears, our desire to create and our concern about what happens when our creations surpass us. These beings would walk among us, learn from us, and perhaps even surpass us. They would not only mimic human behavior, but also adapt and evolve, becoming partners in our daily lives. The vision of robots seamlessly integrating into society has long been a hallmark of futuristic storytelling. Today, that dream is rapidly becoming a reality. Advances in robotics and artificial intelligence have brought us closer than ever to creating machines that not only look human, but also think and act in ways that are strikingly similar to us. Humanoid robots, machines designed to mirror the form and function of the human body, are no longer confined to the realm of science fiction. They are emerging as a tangible reality, with applications ranging from healthcare and education to entertainment and beyond. They are here, and they are poised to revolutionize our world. These robots are not just tools, they are collaborators, capable of performing tasks that were once thought to be uniquely human. From assisting in surgeries to providing companionship, their potential is vast and transformative. These machines are not merely mimicking our movements. They are designed to replicate the subtleties of human gestures, expressions, and interactions. This level of precision allows them to engage with us in ways that feel natural and intuitive. They are being imbued with the ability to think, learn, and interact with their environments in increasingly sophisticated ways. Through advanced AI, these robots can analyze data, make decisions, and even predict human needs, making them invaluable in a variety of settings. This new generation of robots is pushing the boundaries of engineering, artificial intelligence, and our understanding of what it means to be human. As they evolve, they challenge us to rethink our relationship with technology and the very definition of humanity itself. At the forefront of this technological revolution stands Protoclone, a groundbreaking humanoid robot developed by Engineered Arts, a UK-based robotics company. Protoclone represents a paradigm shift in robotics, moving away from the traditional rigid-limbed machines of the past and embracing a more biologically inspired design. What sets Protoclone apart is its revolutionary musculoskeletal system. Unlike conventional robots that rely on motors and gears for movement, Protoclone utilizes an intricate network of artificial muscles and tendons that mimic the structure and function of the human body. This innovative approach not only allows for smoother, more natural motion, but also opens up a world of possibilities in terms of dexterity, strength, and adaptability. To understand the significance of Protoclone, one must delve into the intricacies of its design. This revolutionary humanoid robot represents a fusion of cutting-edge technology and bio-inspired engineering, pushing the boundaries of what robotics can achieve. Every component, from its skeletal structure to its artificial muscles, has been meticulously crafted to replicate human-like functionality while surpassing biological limitations. Each artificial muscle is a marvel of engineering, composed of advanced materials that contract and expand in response to electrical signals, just like their biological counterparts. These materials are not only lightweight but also incredibly durable, ensuring that Protoclone can perform complex tasks with precision and reliability. The development of these muscles required years of research, combining principles from biology, physics, and material science. These muscles are strategically positioned throughout the robot's body, allowing for a wide range of movements, from subtle gestures to powerful leaps. This precise placement enables Protoclone to mimic human motion with uncanny accuracy, whether it's performing delicate tasks or demonstrating feats of strength. The result is a robot that moves not just efficiently, but almost lifelike, bridging the gap between machine and organism. But the innovation doesn't stop there. Protoclone's creators have gone beyond replicating human motion. They've also addressed one of the most critical challenges in robotics: thermal management. Protoclone is equipped with a sophisticated thermal regulation system that mimics human perspiration. This groundbreaking feature allows the robot to maintain optimal operating temperatures, even during prolonged or intense activity. By dissipating heat efficiently, Protoclone can sustain high performance without the risk of overheating, a common issue in advanced robotics. This system, a world first in humanoid robotics, helps prevent overheating during periods of intense activity, ensuring optimal performance and longevity. It represents a significant leap forward in making robots more autonomous and capable of functioning in diverse environments, from industrial settings to disaster zones. With its groundbreaking musculoskeletal design and advanced thermal regulation, Protoclone is not just a robot, it's a glimpse into the future of bio-inspired engineering. It stands as a testament to human ingenuity, showcasing how technology can draw inspiration from nature to create machines that are not only functional, but also remarkably lifelike. Protoclone is more than a technological achievement. It's a vision of what the future holds for robotics and humanity. While Protoclone showcases the potential of musculoskeletal technology, it's just one example of how robotics is pushing the boundaries of human-like movement. Engineers and researchers are constantly innovating to create machines that not only mimic human agility but often surpass it. Another humanoid robot, the Unitree G1, takes center stage when it comes to pure agility and speed. This robot is not just about running fast. It's about redefining what robots can achieve in terms of dynamic motion. Developed by Unitree Robotics, a Chinese company renowned for its quadrupedal robots, the G1 represents a significant leap forward. Known for their expertise in creating highly capable four-legged machines, Unitree has now ventured into the realm of bipedal robotics with remarkable results. The G1 marks their foray into the world of bipedal machines, and it does so with remarkable finesse. Its ability to balance and move fluidly is a testament to the advanced engineering and design that went into its creation. The G1 is designed for dynamic movement, capable of running, jumping, and adapting to its environment. Whether it's navigating a dirt trail or leaping over obstacles, this robot demonstrates an impressive range of motion. It's not just about speed. The G1 excels in navigating complex terrains with impressive balance and coordination. From rocky paths to uneven ground, it handles challenges with ease, showcasing its versatility. This agility makes it ideal for a wide range of applications, from sports and entertainment to more practical uses. Imagine robots performing dynamic actions on a field, captivating audiences with their precision and grace. Beyond entertainment, the G1's capabilities extend to critical scenarios like search and rescue operations. Its ability to navigate through debris and unstable environments makes it a valuable tool in disaster response. Imagine a robot that can outmaneuver obstacles in a disaster zone, reaching areas that are inaccessible or too dangerous for humans. The G1's agility and precision make it a game changer in such situations. Providing aid and support in hazardous conditions, the G1 is not just a marvel of engineering, but a potential lifesaver. Its ability to deliver medical supplies or assist in dangerous areas highlights the profound impact robotics can have on our world. The Unitree G1 isn't just content with laboratory tests and controlled demonstrations, it's ready to compete on the world stage. In a groundbreaking event, the G1 participated in the Beijing Marathon, running alongside human athletes in a testament to its endurance and capability. This event wasn't about robots replacing human runners. It was about showcasing the potential of humanoid robots to push the boundaries of what's possible and, inspire the next generation of engineers and athletes. The G1, with its sleek design and impressive stamina, served as a powerful symbol of the future of robotics in sports and beyond. The advancements in humanoid robots go beyond just mimicking human appearance. They delve into replicating the very functions that make us human. The development of artificial muscles and thermal regulation systems, like those found in Protoclone and Unitree G1, are prime examples of this bio-inspired engineering. These fluid-powered muscles, often composed of advanced polymers or electroactive materials, contract and expand in response to electrical signals, mimicking the movements of human muscles. Pretty fascinating, right? Similarly, the cooling systems, inspired by human perspiration, utilize microfluidic channels and evaporative cooling techniques to regulate temperature. This prevents overheating and ensures optimal performance. It's like giving robots their own version of sweat. The potential applications of humanoid robots extend far beyond the realm of sports and entertainment. These machines, with their human-like dexterity and adaptability, are poised to revolutionize healthcare, disaster relief, and even our daily lives. Imagine a world where humanoid robots assist surgeons in delicate procedures, their steady hands and enhanced vision, allowing for greater precision and reduced risk. Wow, just think about that. Picture these robots navigating rubble in the aftermath of an earthquake, searching for survivors and providing critical aid. And envision a future where humanoid robots assist the elderly with daily tasks, offering companionship and support. It's not just science fiction anymore. It's a glimpse into what could soon be reality. As humanoid robots become increasingly integrated into our lives, it's crucial to address the ethical implications of their existence. Questions about robot rights, autonomy, and the potential displacement of human workers must be carefully considered. I mean, should robots be granted the same rights as humans? How do we ensure that these machines are used ethically and responsibly? These are complex questions with no easy answers, that's for sure. As we venture further into the uncharted territory of human-robot interaction, open dialogue, thoughtful consideration, and careful planning are essential. It's a conversation we need to have, and soon. The future of humanity is inextricably linked to the development of humanoid robots. These machines have the potential to enhance our lives in countless ways, but they also present us with unprecedented challenges. As we stand on the cusp of this new era, it's our responsibility to approach the development and integration of humanoid robots with both enthusiasm and caution. By embracing innovation while upholding ethical considerations, we can harness the power of this technology to create a brighter future for all. The journey into the age of humanoid robots is just beginning, and it's a journey we must undertake together. Exciting times ahead, don't you think?
Love exploring the world of technology and AI? Don't forget to like, share, and subscribe to NeoTechLens for more insightful and exciting content. Hit the bell icon to stay updated with our latest tech and AI innovations. Your support fuels our journey into the future of technology.